the conversion of class diagrams to ERDs, yeah? So ERD is entity relationship diagram. Okay, so um, in a class diagram looks like this. Okay, so you might have customer, and then you have attributes, then methods. Yeah. So your um in your modeling, what you're wanting to do. Okay, so the purpose of modeling, yeah, is you're using systems thinking. Yeah. Your problem definition, you're using computational thinking. Okay, all good. So give me a smiley face, confused face. You follow that? All good. Now it's very, very important that you get this, because that's the whole process that we go through. And you must be comfortable with this, yeah? So in modeling, what you're doing is you're taking the physical situation, and you are saying what, why, who, where, and all that. Okay, what has to be done, right? Real, and then you define it as a problem. So now you have a digital problem. Okay, see the process there, and then you move on to be able then to create your digital solution. Yeah, all good. Yep. So once you can see that, you will see a process, yeah, that you go through. Okay, so you have a use case. Yeah, your use case breaks down into the different parts of your system. So you might have a quote system. Yeah, your uh, so your quote system, within that quote you will have activity flow. Yeah, you would also have data flow. Okay, your activity flow and data flow, yeah, are basically the same sort of thing. Yeah, your activity, once you understand the activity flow, you will understand how the data will flow as well. Okay, all good. So your code system is one use case. Smiley face, confused face. Any questions? Everybody understands that, yeah? Okay, good. So once you have your activity flow, from your activity flow, you can then change it into a algorithm. Yep. And from your algorithm, you create your pseudocode. And then from pseudocode, you go into code. Yeah. So by the time you get here, that's your digital solution. Over here is your digital problem. Okay. So you can see how that that flows, and then you can see that when you do that, it gives to you, it breaks down your digital problem, and then it uh, cracks open what actually has to happen, right? Then you develop your algorithm, pseudocode, and then from pseudocode to code, it's pretty easy then. Okay, so hopefully you should have had that done in FA1. Okay, all good. And so in your use case, you would also have a job. Yeah, yeah, data is going to come very soon. Yeah. Okay. Uh, and I explained that to you in my email. Did you get that? Okay. Don't worry too much about that yet. I will answer that to you for you directly. Yeah. So you can have a job. The job. Okay. So what happens with the job? Again, you go through the same. You go through the same thing there. Okay. You got to have another use case of with your job. You have to create your invoice. Yep. Okay. Payments. These are all use cases. Yeah. Smiley face, confused face. All good. All right. So it's tedious. I know it's tedious, but you're breaking it down one by one. So that's your use case. So for our UML, we are looking at, so this is UML, yeah. This one here is also UML. We're only looking at three. They are 14 if you remember rightly, yeah. If you are in a commercial environment and dealing with a big project with a team, then there will be lots of other things that you can actually use to help control your how you would come up with a digital solution. Okay. Now the next one that we want to look at, of course, is our class diagram. Yeah. Your class diagram uh, describes what entities they are, and remember, entities are not just people, departments. Yeah. Not when you think entities, you think that is what it means, but it's more than that. A job is also a class. Yeah. An invoice, a quote. Yeah. That's all. That's all classes. Okay. Now again, as you understand, when you break down your do your modeling, there is more than one way to represent the digital problem. Okay, so you could look at completely three different ones, or you could have, say, one and you call it a job. Yeah, but the job could be a quote, or it could be what do you call it, a job. Yeah. Okay, so that you could use a flag. Okay, that says quote, for example, job. Okay, as a a flag that says, okay, now when you start everything starts with a quote, then it becomes a job. Okay. But what then when you look at it, what then you might ask, what about existing jobs that you have, that maybe lawn mowing? Yeah. You've got a customer every month you go, or every 3 weeks you go and cut their thing. Okay, so you got to be able to handle that, and that's handled in your system design. Okay, so coming back to our class diagram, your classes are, the way you do it is you have a title. So customer, yeah. Your customer has attributes and it has methods, yeah. So when you look at your classes conversion, okay, you're converting class diagrams to ERD. Okay, so these are the rules, yeah. All right, the first rule is one, every class is a table. Okay, ERD is a entity relationship diagram, but this here is within coding is database, yeah. Okay, so all that, when you look at the whole process, okay, your code, activity flow, algorithm, pseudocode to code, that that digital problem moving to digital solution, okay, is also shown here. So when you have a digital class diagram, that is a description of your system. You're wanting now to move onto the coding area. Right? Within the code, you have a database, right? And that's what we do. That's what we're doing. Yeah. Smiley face, confused face. Okay. You need to make sure that you understand that. Okay. And why we are doing that. Yeah. Okay. So that's the first rule. Number one, your classes become every class becomes a table, and so you can see very clearly, if you don't do this well, then this is going to be wrong. If this is wrong, that will be wrong as well. That's why it's very important to get the early stages all right. Your problem definition, your modeling, all that should be right, so that we can convert our class diagrams into something that is uh, uh, that can become a digital solution. All right. Okay. So that's the first rule. Second rule is attributes become fields. Okay. Three. I'll explain these details to you later on. Yeah? Then you map one to many relationships. This is where you introduce primary keys and foreign keys. Yeah. So these are shown by arrows. Yeah. Or relationship. It shows relationships. Okay. Fourth, if you have many to many relationships, and so these two are where we have cardinality. Yeah. Remember, in your class diagrams, you show that. Okay. Um, for example, you have your customer. Yep. Customer can have uh, customer asks for quote. Okay. So you have a quote here. One customer can have many quotes. Smiley face, confused face. Yeah. And so this ask for quotes explains what happens in the real world. So you have an entity, a customer, And then you have an entity here, which is quote. Yeah. Okay. And the relationship, how you create this quote is when the customer asks for a quote. Right? Your cardinality is shown. One customer can have many quotes. Follow? Okay. And here, uh, 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 I will show you later on. When you convert that to a table, yeah, because you have one to many, you must have a primary key and a foreign key. Yeah. The foreign key is stored in this table. This is actually not a table at the moment, but later on I'll show you how in the entity relationship diagram that links in. But what you're doing is this foreign key, yeah, says that this quote belongs to this customer. Okay, so when the primary key is stored in here, that primary key is exactly the same. Yeah. So this value and this value are the same. Follow? Okay. So when this value, which says customer number uh, 526, this is also customer number 526. Okay. The database then says, because this foreign key sits in this quote, then this quote, yeah, this quote belongs to this customer. Okay, and what that does is that ties that together. Smiley face, confused face. So Josh, you understand what a foreign key, primary key does? James, Josh, Stephen, all good? Yep. Does that answer your question? Okay, and then when you come into to looking at so those are the other rules there. If you have a many to many relationship, okay, you need to create an extra table, and this is where you have composite keys, yeah, and you would put your primary key, two primary keys together, yeah, two primary keys together, and it links your data together through that relationship. That would be when you're creating. So if you do in your restaurant setup, you have a table, yeah, not table database table, but the customer where the customer sits, yeah, the diner sits. You have a table. The table places an order. An order has many lines. Okay, so that is a many to many relationship. Okay, so it has to link every line. So order line has to link to a menu. Okay, so that's many orders to many menu items. Okay, so many orders, order line, yeah, to many menu items. Okay, so then you have to have the primary key from here and the primary key from here. You add them up. That there gives you a unique. Okay, so for that order line, for that order, you have the primary key to the order. Yeah. So for the order line, sorry. Okay, coming back. Yeah. So coming back to restaurant. So you have your menu. Okay, so you have your and this is tables now, yeah. Okay, so you have your different menus. You have your order line. Okay, and that belongs to the order. Okay, so so which that order uh, line, so that there is stored in a table, pk plus pk, yeah, and that there is linked to that. Okay, but so that and that are linked together. Okay, does that make sense? Smiley face, confused face. It will make a lot more sense once you actually get into create your system. In your handy Andy system, you might list down types of jobs. Yeah, plumbing. You might have services. You might have electrician, plumber. How many hours? Yes, that's right. So this one would be 1, 2, 3, 4. Yeah. So these are all primary keys. Yeah. So that's a primary key. That there. 1, 2, 3, 4. That's also a primary key. Yeah. So when you have primary key one plus primary key two, what you're having is you are linking or composite. Right. So what we're saying is for that line order is made up of two items, one and two. And that order, that how it's shown is that table. Okay? All good? Does that make sense? Have a think of it. Okay, everybody else, give me a smiley face, confused face. All good? Are you still there? Okay, James? Okay, all good. So coming to how it actually looks then, yeah? So if you have your customer, we're going to ignore the methods first. Remember, your methods become actual code itself, yeah. And so in the customer one, okay, you might have these methods: add customer, delete, edit, yeah. Okay, so here's a customer. You have your ID, name, surname, okay, email, phone, address. You get the idea, yeah? You could have as many as you want. Okay, so when you create a table, the table now looks like this, yeah? And remember, this is a class. It's not a record, yeah? It's a description of all objects that belong to that class. The record is an instance. Okay? Smiley face, confused face. So, John Smith is a customer, and John Smith, yeah, John Smith, John Brown All of them uh, can be described with this class. Okay, all right. But John Smith is different from John Brown, and how you know they are different is your ID or your primary key. Yeah. So every ID is an instance of that class. All good? Smiley face, confused face. Connor, James. Okay, all good. Right. So, so this is UML. This is ERD. Okay. This is a class. This is a table. Okay. Now, at the top of the table is where so you have your so this is your customer table. Yeah. What you would have would be ID, name, yeah, uh, surname, email, phone, address. And so you can see, okay, your ID goes there, your name goes there, your surname goes there, email goes there, and so on. Yeah. Now, when you have records, so these are record, okay. A record is the same, yeah, as an instance. Okay, so every instance is a record. All good? Smiley face, confused face. All good? So every class becomes a table. Okay? So in your database, okay, you have one file. That's how you represent a file, right? But within that file are many tables, right? Within the table, within the table, within each table are records. Yes, follow. Yep. And then the tables are related. Yeah. Tables are related. So this is why we call it relational database. Okay. All good. Smiley face, confused face. And so that is why we have ERDs, entity, relationship, yeah, relationship diagrams, yeah. Now, the way relationship entity relation entity relationship diagrams evolve, uh, I can address some of those questions you may have, but it has to be questions, yeah, because we've already covered how objects are, uh, how you make room for objects to model in a system, yeah. But so you think about what questions you want to ask, and I will address that as we go. Okay, so where did entity relationship diagrams come from? They came from back in the day when databases started coming out, and it was a very conceptual thing. Okay, today when we have UML and we got modeling tools, okay, your entity relationship diagrams are still important because what it create helps it helps us create the database. Okay, so if you come back here, you will see your modeling moves on through to your digital solution. Digital problem moves through digital solution. Okay, each step of the way we are going through, yeah, the decomposition and the translation into whatever we are uh, trying to create in terms of the digital solution. Okay, smiley face, confused face. Uh, where are we now? Okay, why is it? Okay, it got shifted. So we have entity relationship diagrams. They are important because we use them to create databases. And entity relationship diagrams look something like this. Okay, so you have a customer. The customer has ID. Yeah, so the ID is a primary key. You got your name, surname, email, okay, address, phone. Okay, then you could have a code. Okay, you have an ID, right? And then you would also then have customer ID. Okay, and that customer ID is the same as that primary key there. Now this is a foreign key. Okay, all good. And so in your database, so this is a database, you would have many tables, yeah, with relationships that are described, say one to many, yeah, and so on. Okay, and so your so this is a database. These are your tables, and then each one is a record. Okay, record. All right, so this is a table. Your attributes are up at the top. They are called fields. Yeah, fields. Okay, again fields, and then so uh, fields, and then here are records. The top one is fields. Yep, and then the bottom ones are records. Okay, and of course you would have your relational uh, links as well. Yeah, obviously the links are either primary key or foreign key. These are the only ways that the tables are linked. Okay, so your primary key and foreign key. Your foreign key links to your primary key of another table. You could have a composite key, yeah, and that could also be linked to uh yeah, another table. Okay, all good. Smiley face, confused face. Okay, so quick quiz now. How many files, how many databases does a system or an app have? One. One. Very good. Okay, so your app sits in your folder. Yeah, it has one database. Yep. If it's done properly, it will have one. Okay, but if you are trying to access another database to pull data in later on, that's unit three. We talk about APIs and all that. Yeah. Okay, so very good. So you understand that one database. Now within that database, how many tables do you have? As many as you need. Very good. Okay, very good. Yes. And within each table, how many records would you have? What do you think? Anybody? Now, as many as you need. Again, yeah. Okay, so the database thing using uh, primary keys and foreign keys, okay, enables you to have what we call uh, direct uh, yeah, direct access. Okay. Uh, back in the day, back in the day, when data was not kept in hard drives, yeah, data was kept in tape with using tape. Okay, data was written into onto the tape, yeah, and and when you start, okay, when you start, so this is a long line of tape, yeah, all those records are written in. Okay, so this is sequential access, yeah. Okay, now if you are doing backup and you're copying your whole hard drive, sequential is fine, because what you're doing is you're just mirroring, yeah, your system. Okay, but when you have direct access, you want to be able to access your data directly. You need to use keys, yeah, because the keys are simply pointers. Okay, smiley face, confused face. Yes, no. If your data comes from two tables, then you have a composite key. If or two or more tables, sometimes it can be more, yeah. So if your data comes from two or more tables, you use a composite key. If your data belongs to another record, you have a foreign key. Yes, follow, right? So when you want to have direct access requires you to uh, make sure you organize. Yeah, you must organize. You must show relationships, and then your database management system, DBMS, database management system, does the sorting, does the indexing. Yeah, and all that is done through SQL. Yeah, no, sorry. When you try to access the database, what we use is SQL. Yeah. Okay. Smiley face, confused face. All good. Are there any questions then? Yeah, give me a tick if you're all good. No questions. I'm not going to go too much more. I think that this is enough for you to think about. Okay. Is this helpful? Are you? Is everything clearer for you, or is it more? Have you still got some more questions? Smiley face or confused face, please. James, Stephen, you still there? Okay, all good. So I leave that with you. You can take that away and consider that. Okay. I would like for you to continue with your IA FA2. Okay, so by now your ERDs should be completed. You should have worked through your Python tutorial. Okay, because that's where you do the coding. So if you have not started on that Python tutorial, do you know what I'm talking about when I say the Python tutorial, the SQL tutorial? Yeah, Josh, James, and Connor. Okay, so let me show you again. Um, you should have. Let me get to. Let me open my Freeman. If you already know this, that's good. You should have downloaded your uh, all your mind maps. There are tons of mind maps that were given to you to work through. Okay, so you should be using the scaffolding mind map, and then there is the database mind map. Okay, do you know about the databases mind map? Smiley face, confused face. This one. Have you downloaded it? Okay, so good. So you know that. So this is the tutorial, yeah? So using my SQL Lite, my MySQL, sorry, working with MySQL and Python. There is a database that is built into Python, yeah? And this is already there, doesn't need to be installed, okay? If you double click that, so create a table in SQLite database using Python. Okay, if you double click that, it will open your um, web browser, right? So it will tell you how using Python code you can actually create a table. Okay, so you can see there that there is using ERD documentation. That's a task, a project. One project can have many tasks. Okay, you can see that cardinality. Yeah. So how you create that table is using this code. Okay, and that code is actually uh, SQL. Yeah. Okay, SQL just stands for standard uh, 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 query language. Yeah. You can't see anything. You might have to refresh or come back in. The rest of you, can you see that? Okay. Did you? Could you? Yeah, he's gone. Okay, so can you? How many of you have already started this this set of tutorials? Give me a tick, please. Good, James. Jim. James, good. Uh, Stephen, you started this tutorial. I think I chatted with you earlier. You did. Can you see that now, Josh? Still no. You are with James, right? James, can you see? Okay, good. You can see now. Okay, good. Right. So two things. You have your database mind map. You got this, yeah? Databases, yeah? Okay. Remember, this is very important. You need to know all your data terms and all that. Yeah. We're flipping the class. All right. This will be in the exam next year. Okay. So hold on to this. You're going to be actually using this quite a bit. Okay. Oh, good. But this is where we are working on databases and programming. Okay, then. So I will leave you to continue working on that. Again, we're flipping that, so make sure you are actually doing that and you can understand and it works through for you. Okay? Yep. Are there any questions at all? Give me a tick if you're all good. No questions. If you got any questions, then just key it in. Okay. Connor, James, Stephen. Right. I'll stop talking, stop the recording, and let you get on with it.